Welcome for today's session. So today we are going to talk about our PLC series, and we will. I prepare some setup for you. So we will have a look hardware and software as well. So you will see the contents afterwards. But just before start, I just want to thank you who joined the questionnaire. If you remember, we sent you a questionnaire, and some of you replied. So right now, I more or less know what is the participants' expectation. So as I see, most of you used PLC before, but also most of you haven't used Delta PLC. So that's why we will start with the hardware first. And then I know that some of you joined just for DIADesigner, and then we will jump to the DIADesigner part, software part. So today, around 2 hours we will be together. So in these 2 hours we will try to cover all the hardware and the software just to accelerate your processing. Okay, so let me check. There are some messages. Yes, good morning to everyone. So let me share my screen and then we will start. So today, as I said, it is just 2 hours, but the content is quite intense, so it's good to start as soon as possible. Okay, so first I want to remind you that as a Delta Europe EMEA, we have our own YouTube channel. So according to the questions that we receive from you, we are trying to make some videos, technical tip videos to demonstrate them. So I suggest you to subscribe this channel and try to follow the technical tip videos. Also, you can request some videos from us, so we will try to improve it. The another thing is that I want to remind that we have a download center, so you can find all the documents that we have in the download center. It is centralized, so for any industrial products that we have, you can find all the documents in that download center. And it has a new interface right now. So here you see, a second, let me get the pointer. Here you see there is a, you can choose the product category first, and then find the related document with them, or you can use directly to keywords to search. Okay, so this is centralized area for all documents we have. So today, as I said, we will start with the PLC family as a data what we have, and then we will focus on the AS series, and at the end we will see some success stories, and then we will move to the DIADesigner part. Okay, so PLC product family. So right now we have three main models: DVP series, AS series, and AH series. So if you remember, DVP is the first PLC series that are released, and then we released the AH series for high density capacity projects, and as a last we released AS series. So right now this is our portfolio, but we are still improving ourselves regarding your request. So now we are focusing on CodeSys part, and we will release AX series for PLC as well. Maybe if you heard that we released AX series for motion controller, but not only motion controller, but we will also release PLC for CodeSys. Okay. And the important thing is that this studio, our new environment, software environment, will support AS series and AH series. DVP series is not supported with this studio, let's say DIADesigner for PLC programming. And here you can see the more or less where it is located. For AS series, we mainly focus on machine and factory automation. For AH, process automation mainly, and factory automation sometimes, and DVP also between machine and factory automation. So this is the family that we have in our portfolio. But these are just families, but there are many sub-models, and it is sometimes quite difficult to choose which CPU is right for my application. So this scheme shows that more or less how can we decide which PLC series we should go through. Here you can see we have we can categorize like micro, modular, and rack. And then the main important thing is that I/O point. So for instance, if you don't need a less than 500 I/O, then you can go with the DVP basic series. Or if you need some I/O points more than 1,000, then we should go with the 8 series. So this is the first separation part. First, we need to define how many I/O do we need. And then for sure, the capacity of the PLC. So here you see the capacity of the PLC is quite diversity. So for AS, I can say like 64 to 128. And at the bottom, you can see the execution time. And according to these 3 major factors, we can choose one of these families. Okay. And it was just for CPU, but maybe you don't know, but our PLCs are modular. So you choosing CPU is not enough. We need to customize it regarding the application. So here you need to choose a module for digital or analog I/O. We need to choose maybe network communication modules if needs in the project, remote I/O or local master-slave communication, or it can be also function-based modules like temperature controller, motion controller, or load cell controller, weight controller. So we have different modules. So it depends on your application. You should customize your configuration. And this is AS series. Let's move on to AS series. In AS series, we have 2 main models, AS 300 and 200. So this is 300, and 300 has a built-in I/O. And this built-in I/O supports pulse output, hardware interrupt, high-speed counter, and standard input-output points. And we have Ethernet port on it, which supports Modbus TCP and Ethernet IP. And at the same time, it can be used for programming as well. We have RS485 port. At the bottom, we cannot see right now, but we have 2 ports for RS485. We have a function card slot. This is empty slot, so we can customize it. We have serial function cards, communication function cards, and analog function cards. Apart from modules, we have also modules, but to customize the CPU itself, we have empty slot to customize with some function cards. And here under this cover, there is a mini USB, and it can be used for programming. And this programming can be used for 2 environment, ISPsoft and DIADesigner. And we have also micro SD card in it to back up or restore the PLC project or receive an error code logging. And this is AS200. So here, what is the main difference? There is a built-in I/O, but the connector type is different. For the AS300, it was mill connector, but this is push-in connector. And this is AS200 also supports pulse output, hardware interrupt, high-speed counter, and digital I/O. And we have Ethernet port as well. Same port, Modbus TCP and Ethernet IP at the same time, and can be used for programming as well. And we have RS485 port as we have in AS300. We have mini USB for programming, and we have it also supports micro SD. So it also supports DIADesigner. So we can program in DIADesigner and ISPsoft. And another main difference between 300 and 200 is that in 200 series, there was a function card slot. But in 200, there is no function card slot, but there is an embedded can open. Okay, so this is the another main difference between 2 models. Okay, quickly have a look to specs. So AS300 has a 128 kilo step program capacity, which is more or less, we can say, 1 step 4 byte, so around 512 kilobyte. And execution speed for 1 contact, only 25 nanoseconds. And it supports up to 32 modules, I/O modules, and up to 1024 digital points. So what does it mean? We need to consider both of them when we are choosing the configuration. So here, let's say that we have 10 modules only, and we reached to 1024 points already. So you cannot put another digital I/O module over here because you reached the maximum I/O point. Okay, so we need to consider these two at the same time. But you can use for network modules, for instance. Okay, and we talk about them. So for the AS300, CanOpen and Ethernet IP and also Profinet allows us to make a remote I/O solution. I will show it to you, and we will talk about it as well. So here, what I want to mention, CanOpen, it supports CanOpen DS301 position control standard. So you can use CPU as a CanOpen master to control slave devices, CanOpen slave devices. And here you see there are different types of CPU, and here according to output type, the code is changing. So here you see this is MPN output, and the code is T, and for PNP it is P. So the code is changing, depends on the output type. Okay, and we have one model which has no digital input output on it, and we have another model with the pushing connector shown here. Okay, 200 AS200 program capacity is like a yes, smaller than 300. It is 64 kilosteps, so around 258 kilobyte. Execution speed is 25 nanosecond for one contact only, and same expansion unit and the I/O same as 300. And there is a CanOpen embedded port which supports CanOpen remote I/O solution. Remote I/O solution also possible with Ethernet IP and Profinet communication networks. And like AS300, AS200 also depends on the output type. Then depends on the output type, you can choose the different models. And we have one series which has a built-in analog input output. So for the small application, instead of getting an analog module separately, if the resolution is fine, you can go with the built-in analog input output. Yeah, high performance. Why we are calling it high performance? Because inside we have our own CPU. So AS series have a Delta spatial CPU in it, and you see the numbers here. So AS300 only one contact execution time is 25 nanoseconds, and for move command, move instruction, it is only 0.15 microseconds. So let's think about a program, user project, which is around, let's say that 40 kilostep, and it consists of 40% contacts and 60% move instruction. And for this program, the execution speed is 1 millisecond only. So it is just a reference for you. And what I want to highlight here, normally for the other PLCs, let's go. One scan time, most of time includes program execution and updating outputs and inputs of the modules. So these all three combine in one scan time. But in our AS series, updating output and input modules simultaneously with the program execution. So it makes CPU faster when we compare the others. Okay, let's have a look key features. So first one I want to highlight is that SD card. So we mentioned that CPU supports SD card, and this SD card allows us to store our user project, PLC project. And so for the remote support, we can make the change in the project in our factory, let's say, and then export it to SD card, ship it to the machine builder, and they can import it. So And this is, since it is not directly the same project, this is a kind of execution file. So they don't need to open the ISPsoft or DIADesigner, and they don't know how to connect PLC, etc. So they just simply plug the SD card and download to PLC. So there is no need to any knowledge, PLC knowledge for the end user. And also you can protect your user project, source code, I mean. And the other thing I want to highlight is that we have a permanent data backup. So it means that when you switch off the PLC, the data you stored in the PLC will not be removed. So when you power it on, it will be there still. And for this, no battery required. When we need battery, for the real-time clock applications. So if you need something that you need to use real-time clock, then you need to use an additional battery to keep the history, to keep the time information in it. Okay, but for the data, we don't need any battery. And yes, it is easy to install. Why we are calling easy to install? Because here you see in one rank, if we want to change one of them, we don't need to break all of them. We can pull them separately. So here there is a clean. So you just need to pull it up, and then you can take the module, and then you can push it back to change any module. So you don't need to break all the configuration. And yes, when we compare the size, it is quite small, and this is an advantage, especially for the panel builders. In the panel, it will not take a space. And also, we support different connector types for digital input and outputs. So here you see for the more than 32 digital IOs points, we use mil connector. And for the 8 or 16 modules, you can also prefer pushing modules. Okay, let's have a look industrial network 2. So these are the CPU which supports function card, and we have a communication module which also supports those function cards. So we can customize the CPU, AS300 CPU, or the communication card. So here you see we have two serial communication function card, and this is CANopen function card. And this CANopen can be used as a remote I/O, as I said, also can be used as master or slave. And for the Ethernet IP, we have a function card, dedicated function card, which can be scanner and adapter. So this is separate from the CPU. I mentioned before that CPU itself supports Ethernet IP. That's okay. But also we have additional function card which supports specifically for Ethernet IP. And we released Profinet function card as well. So it can be a slave. So for the Profinet configurations, AS can be one of the slave part in that network. And for the device net, we have module as well, and it can be master. And in addition, what we will release OPC function card. So you know OPC UA, especially for the information layer, it's quite important. So we will release OPC function card to reach from any SCADA or web application easily. And we will also release IO-Link module. And IO-Link module is quite important for especially the applications like predictive maintenance. So with this module, we can get the information, not only the status of the on-off of the digital points, but also we can get the information, additional information from the sensors directly from the field with this module. Okay, so these are all the function cards related to industrial network. Okay, let's have a look. Built-in Ethernet port on the CPU, AS CPU. So we said that it supports Modbus TCP and Ethernet IP. But in addition, AS CPU supports email. So we can send an email from CPU. It supports web server. So it is possible to monitor some data from the browser directly. So for instance, in the factory, for management, let's say, if they want to check some values, they don't need to know how to program or how to connect PLC. They simply open the web browser, type the IP address, and they can see the value that you registered over there. And also supports flexible topologies like linear and star topology. And for Ethernet IP, here you see an example, and up to 32 CIP connections supported. And maximum capacity is 500 bytes per package. And update time is 1 CPU scan only. So here you see you can make a Ethernet connection for Ethernet IP, or it's also possible with our wireless modems. You can make a wireless communication with another CPU. Okay, we have a question. Is power module mandatory for AS series or optional? Thank you for the question. I forgot to mention. No, it is not mandatory. It is 24 volts only. So you can use your own power supply. But in addition, we have also our power supply like AS-PS02. So it is simply power supply. So no, it is not mandatory. You can also supply with your own 24 volt DC in your cabinet. Thank you for the question. Okay. I'll keep going. So we talk about that the SCM module. This is communication module, this is communication module, but you need to plug function card, and it allows you to use two. But for some function cards, you need to mount only one. Nevertheless, this is a communication card and supports 3 serial communication cards and can open Ethernet IP and Profinet. Okay, and let's see the functions. So for these 3 serial COM ports, it supports standard Modbus protocol for sure and user-defined protocols. What is user-defined protocols? Some devices which is not industrial use serial communication without any protocol. It can be called no protocol. But what it can be, for instance, for master, it can be like a barcode scanner or LED display. So these are not really industrial products, so they don't support standard Modbus. So then you need to define your own protocol, and these cards allows you to do it. So you can connect with or printer. You can send the data from PLC to printer with RS-232, for instance. Okay. And can open function card. It supports slave mode and RTU mode. What is RTU mode? Remote terminal unit. So it is a remote I/O solution. I will show it later. And Ethernet function card also supports RTU mode or standard Ethernet IP, and Profinet slave only, and also supports remote I/O solution. So this is the remote I/O solution. The idea is that, okay, we have CPU and we can mount up to 32 modules, right? Okay, but let's say that we have a long line in the mission, and let's say that at the end of mission there is some I/O points, like 10 digital input. What you need to do, you need to make a wiring from that 10 digital input to cabinet where the PLC is located. So it is extra cost. So instead of that, you can make a small cabinet over there, and you use this communication module only. This is not a logic control. This is just a communication module, and mount the function cards or I/O points nearby it. Okay. Then make the wiring these modules. So the communication card will send the status of the points of the modules to CPU directly. So the advantage is that you don't need to make a wiring, or you don't need to make any wiring. you can get directly all the information from the remote points. And it supports up to 100 meters. So up to 100 meters, you can mount one. And you can choose depends on you actually. There is not really a difference between, but you can choose any of the protocol, CAN-open, Profinet, Ethernet IP. So 3 of them supports this function. So yeah, this is the remote I/O solution, and we support it. Okay. I/O using. Okay, I guess before going to I/O using, regarding the specification, if there is any question, please let me know. Otherwise, I will keep going. So it was the specification part. I just want to finish it quickly. Then we will focus on the applications. Okay, I guess no question. Is there a question? Sorry, I cannot read your name. Okay, one participant raised their hand. Is there a question? Okay, I assume no. Okay, I'll keep going. Wait a second. Yes, I/O using. So, before understand the I/O using, we first need to understand memory area, how the memory area works in Delta PLC. So, on the left-hand side, you see the table. And in this table, we have a bit device and word device. Well, actually, word memory and bit memory. And you see in the word memory, there are some memory areas which is same. So it means that these memory areas can be used as a word or bit, okay? For instance, here we have a M memory area, which is not included word area. So M can be used as a bit only. So this is the hardware specification. And here you see, for instance, let's focus on the input relay and output relay. This is the real physical input and output address. This is where it starts. So x0.0. So the first digit 0 means the channel, and the dot 0 or dot 1, this is the bit position in that area. So here, if we want to use any digital input, first we need to define the channel itself and the which bits of that channel we need to define. And same for the output. So this is how we use as a bit. But if we want to use as a word, we just need to define channel itself, okay? And each channel has a 16 bit. So in the same principle, we can use data register. And here you see it can be used as a bit or as a channel. So actually it is the same memory area, just allows you to control the 16 bit altogether or 1 bit only bit in a word. So it is quite flexible. So this is specification of the PLC, okay? So you need to understand that, okay, for the input, physical input, I need to use X channel. For the output, digital output, I need to use Y output, okay? So M is only bit, so I cannot type M0.0, no need, because it cannot be word. So you need to define it as M0, M1, but still it means bits only, okay? So this is the memory area. Let's turn back to right side. So normally for the software programming, what we are doing, we are defining the variable, right? And we don't think about where this variable is stored in the PC itself, right? We just define the variable and it is stored somewhere in the PC, and we don't care because we don't have any limitation on the hardware. But here we are talking about PLC, and there are limitations, as you see. So for instance, for the data register, you can use up to this point. So for the software engineering, what we are doing, we are defining the data type, variable name, and the value itself. And it is stored somewhere in the in the PC. But for the PLC programming, we also need to think about where we want to store this value. So if you want to store a analog value like 3, 5, 7, whatever, so we need to use word area, and this is the word area. For instance, D100. This is just a one channel. So here we are typing D100 is equal 3. That's how we use, and it means that this is word value. So and the data type can be integer or word, but not double word. We need to define it separately. Or what we can do inside the PLC, because in the PLC we also sometimes want to work as variable based. So what we need to do, we need to define variable and address, matching them. It means that, okay, the 100 is your memory area, that's fine. And I will call this memory area in my project as I. Okay. After you define this statement, then you can use your variable. And the value will store the 100 at that. So that is what is the difference between software programming and hardware programming. But on the other hand, it's also possible to assign address automatically. So in that case, you can say that, okay, the I variable can be stored anywhere. I don't care. Then you need to define it auto, but still it is registered somewhere here, and this is limited. So that's why even if you assign it automatically, so still you need to think about that it is stored inside the PLC somewhere, and it is limited. Okay, so this is the main differences. After understood that table, let's go to input-output memory. So how does PLC works? Actually, we mentioned that we have an input unit on the PLC and we have an output unit, right? So here, let's say that we make a wiring, and this is the output relay, and this is my user project. Actually, what PLC doing, there is a table behind, and PLC is checking that table. So here, checking the table and also the user project. For instance, at the beginning, x0.0, this is the real first digital input, is 0. Well, checking the table, and it is 0. So saying that, okay, if it is 0, this is false, and it is false. But when we push the button, the input unit update the table, okay, and 0.0 become true, and CPU checks that, okay, if this is true, I need to set 0.3 true too. So 0.3 become true, and output unit reads this line, let's say, and when it is on, it allows to go through to relay. So this is actually how does it work inside the PLC. And here you see the wiring diagram of the CPU. This is AS200RX. This is relay type, but not really different. So here in this CPU, you see we are defining that AIO and analog IO points and digital IO points. So this is where you can see the difference. And on the left-hand side, it is input point. You see in and out, it is defined. And on the right-hand side, you can see how to make wiring. So in the questionnaire, all of you made a digital wiring before, so I will not explain how to make NPN PNP wiring. So I will skip this. Just want to mention one thing. You can make NPN or PNP wiring to our PLC. That's fine. Doesn't matter which model is it. But here you see we have like 8 input point, but 1 common port. So what does it mean? It means that if you make an NPN wiring for first input, the rest has to be NPN too. If you make the PNP wiring for the first input, then the rest has to be PNP as well, because we have only 1 COM port. But for the output, it is different story, because when you are purchasing, you already choose which is NPN or PNP. Okay, so it is defined in the factory itself. So when you got the product, you have to check that if it is NPN or PNP, make the wiring in that case. Yeah, analog I/O units. This is, yeah, I saw a few participants wants to see how does it work. So that's why I prepare analog I/O wiring as well. So we will do some examples. But let me focus on one module only, just as an example. So here for the analog I/O module, what is the important? For this module, for instance, we have voltage output and input. Okay, and also current it should be, but I didn't copy that one. But anyway, so first it is separated like voltage and current. Then inside the voltage, which range you want to work, 0, 10, 0, 5, 1, 5. So these are all depends on the end user. So in the factory or in the PLC project, we cannot know which one you will use. So what you need to do, you need to define in the settings, in the hardware settings of the CPU programming that you are going to use this input as a 0, 10 volt or 1, 5 volt. So this is the first thing. The another thing is that range, conversion range. What is conversion range? It is kind of resolution. So see, actually what this model is doing is that converting from analog to digital, right? So this is the scale. So 0 means 0 in the user project, and 10 volt means 32,000. Okay, but sometimes we don't want to work between 0 to 32,000. We want to create our own scale. So there was some request from a few people. So I will demonstrate how to scale them, how to use in other format. Okay, so on the left hand side, you see the wiring as well. So it supports like 4-wire, 2-wire, voltage input, current input. So these are all possibilities. For the current, what is different? You need to make a shortcut between voltage input and current input. But for the voltage wiring, for instance, here, you don't need to make any shortcut. You can directly wire. So please keep in mind that if you want to wire a current input, you need to make short circuits. And on the other hand, for some modules, this is one of the example, needs additional 24 volt DC. You see here. So you supply the CPU, that's fine, but not enough for this module. You also need to supply 24 volt for this module. Okay. And we talk about that the CPU also supports built-in high-speed input. So for instance, here we see AS200 series, and from 0.0 to 0.7, these are the real digital inputs, supports up to 200 kilohertz. So if you have an encoder which is around 200 kilohertz, you can use these inputs to wire an encoder and to read them. And to read the value, we use the instruction called D counter, DCNT. And for the first part is the number address of the high-speed counter. Here you can see that it's already defined in the factory that if you want to use as an up-down counter, you need to use this address. But if you want to use as a high-speed counter, so high-speed counter, then you need to use this address. Then PLC understood that, okay, the wired item is high speed and it works in a high frequency. Okay, next, high speed output. So pulse output actually. For the pulse output, here you can see, where is it? Number of outputs here, and resist frequency. Yeah, maximum output frequency. So here for the transistor output, up to 200 kilohertz, you can generate pulse from PLC output. When do we need this? For instance, to control step motor or sometimes servo motor. So the CPU allows us to generate pulse output. And while we are doing it, there are many instructions which allows us to use, like with a ramp function or without ramp function. Pulse width modulation is possible. We can make a jog output. Zero return means homing for position control. So relative position, absolute position, these are simple position instructions for pulse control. Okay, so it was the hardware part. Before going to success stories, I will go to software part. So I will continue with the DIADesigner. But before go to DIADesigner, let me check if there is any question. Yes, we have two questions. Is it possible to install two RS-232 modules on one SCM? As far as I remember, yes, SCM modules supports two RS-232 modules. That's fine. But for instance, doesn't support two CANopen cards. Okay, so before use the SCM module, it is good to double check what are the possibilities. But for RS-232, if I am not wrong, yes, it supports up to two. How do we assign I/O to the extended I/O? I'm not sure. How do we assign I/O to the extended I/O? I'm not sure what you mean with the extended I/O. If you try to explain, I will try to answer afterwards. Okay, so how many remote I/O modules can the CPU support? Well, it depends on, let me go back. Here, there is maximum 15 slave and 32 modules. And also you need to think about the I/O point. So there are different combinations. So I mean, for instance, this is up to 15 slaves, but if you reach the 1024 digital input in 13 slaves only, then you cannot wire another one. But if you meet these two conditions, you can mount up to 15 slave points. Let's say that 15 SCM module. Okay. Thank you for the question. Okay, so when we use the Ethernet card to extend or add more CPU, how to assign address to extended CPU? Okay, I guess you are talking about this one. So for the SCM module, for instance, if I connect SCM module, how do I use the address for the I/O modules? I will show it to you, but it is actually it is going respectively. So in the hardware config, you see the address, which address is assigned. So from that table, you can understand. But I can say that it's going respectively. So I mean, let's say that you have one input here, which is X0 channel, right? So the another input is in the remote I/O, and then it is going with X1, and the second one goes with the X2. So it's going respectively. But it's also possible to check in the hardware config. Okay, I hope it was the answer of your question. So let me start with DIAStudio. Okay, DIAStudio. What is DIAStudio? DIAStudio is a suite, smart machine suite. And when we call the DIAStudio, actually we are talking about three main components inside software: DIASelector, DIADesigner, and screen. DIASelector, especially for the pre-sales operations, to choose the right configuration. DIASelector helps us to do it. And DIADesigner for PLC programming, and I will show it later, and DIAScreen for HMI. And here we will focus on these items. So I will skip this. Okay, DIADesigner. So this is our integrated engineering software. So the idea is that having one single engineering software for PLC, distributed I/O, VFD, AC servo systems, and integrated trace and position editor for all the Delta products. Okay, and having network and hardware configuration. So here, for instance, you can see the hardware configuration, and also possible to on the left hand side you see the network configuration. So it allows us to configure more than one device at the same time. And for sure, it supports IEC 61131 standards, PLC open standards. And we have a comprehensive programming editor for efficiency. And we have online functions like test and diagnostic functions. And also it is possible to download more than one device at the same time. So you don't need to connect each device separately. You can connect all at the same time, and you can download all the settings at the same time. So it saves some time for you, hopefully. And integration. So there is an integration between selector and screen. So the project you created in the DIADesigner, you can simply export your variables, easily export your variables to the screen. And it will allow, it makes more flexible. So the question may be raising in your head that why should I change my current engineering software? So it doesn't mean that ISP software will be phased out or something. No, we will use them together. And you see, there are two different targets. For DVP, this is for Mission Suite. So that's why it's included S and AH most of the time. And for DVP, still we need to use ISP soft. So it is not like direct replacement. Okay, just depends on your request. So, but the idea is that minimize the downtime with the downtime with the integrated diagnostic functions. Okay, and flexibility for production with the integrated communication tools, and improve the engineering efficiency for lower cost, and global standards for simplified implementation, and flexible simulation for process validation. So the idea is that minimize the engineering time, fully integrated and more flexible. So for the machine applications, I hope it will help you. So let's talk about supported devices. So far, DIADesigner supports AH series only, and AH will be supported as well. For the AC drive, it supports C and M families, and also EL, yes. For servo drive, it supports A2, A3, B2, B3, M series, and also supports temperature controller DTC modules. So these all products can be used in one project only in DIADesigner. So how to install and update? Actually, we already sent you an email how to do it. So we have a specific website for it. So you download the installer, and when you download the installer, you see which components we have inside. And the good thing is that it is centralized. So if there is any update in the software, we all receive at the same time. Okay, and so yeah, we will get the notification immediately. The idea is that to see the latest version and updates notification, also centralized manual and automatic updates, etc. Okay. How about user interface for DIADesigner? Right now, today we will focus on DIADesigner for PLC programming. So in DIADesigner, there are two different views: basic view and advanced view. So here you see the basic view. When you open the start project, you will see the basic view, and it provides some quick access tools for us to manage the project itself. So in the basic view, it is simple interface. It allows project management and project immigration, and also sequence the complete basic settings. And there are wizards for servo and VFD. So what we need these wizards? So for instance, if you want to connect one drive only, and you just want to connect the drive and check the parameter quickly, then you can use this wizard instead of creating a project. And advanced view. So here you see advanced view, and on the left hand side there is a project menu, and on the right hand side you see the programming area, and these are let me get the pointer. Yeah, on the top you see the useful tools and the menu. So we will see them separately. Here there is it is possible to transit from DIADesigner to selector or screen easily. And it is possible to migrate an old project, I mean ISPsoft project. So here we can go to project migrate to transfer from ISPsoft to DIADesigner automatically. And here on the left hand side you see the tree menu, and here you can see the item and sub items. And this is the quick tool to manage the project. And this is an example from the servo parameter, for instance. So this is how it looks like. So we have two different views, basic and advanced view. For project management, here you see we call it one software for all automation products. Here, for instance, you can see in one tab, I can see the drive parameters, and then I can go to the PLC side and keep programming on the PLC side. Here, for instance, in a one project, there are 1, 2, 3 controller, one servo, maybe one VFD. So you can customize your project and you can simply switch between the pages. And the project migration, I mentioned it. It is possible to import ISPsoft projects to DIADesigner. Not only PLC project, but also drive parameters. It is possible to import drive parameters from VFDsoft to DIADesigner. Okay, for project overview, yeah, these are general settings. I'm sure when you are playing, you will discover them. So I will skip. Com manager. So, you know, we also update the com manager, which is also compatible with the ISPsoft. So you can keep going with the new version. So the idea is that here interfaces change. And also the good thing is that com manager can search up to 3 layers. So what does it mean? For instance, you use USB to connect one PLC, and then you can reach the other devices which is connected to the first PLC from the COM port, for instance. So here I can also control these modules via the first PLC. Okay, so you don't need, if your PLC is connected already with that drive, you don't need to connect to that drive specifically. You can go through the first one. And here you see from first PLC, we go to the second PLC, and from second PLC Ethernet port, we can go to the another one. So we can reach up to third layer device. This is something I really like personally. Okay, what else? And com manager and their cloud, it was already the support, but there are some optimization in that part. So their cloud performance, I mean com manager performance increased for their cloud. So you can simply connect devices remotely with DX router. If you are not aware that we have a router, industrial IoT router, which allows us to manage devices remotely. So we have DIACom in our PC, and this DIACom open a port, VPN port tunnel via DIACloud to device. So from the softwares we can remotely connect, upload, download, etc. Okay, device control. So there are two main way to add a device in the studio, which is manually and automatically. For manually, there are different ways, like from the quick or basic view, you can create a new device, or from the advanced view project explorer, you can create a device, or from operation, or basically from the icon. So this is how we add manually, but it's also possible to scan network to add devices to project directly. So when we need, for instance, we have a device, but we don't know which model it is. So then we can use network scan. So it just use the com manager driver and check the existing devices on it and brings all the devices to your topology. Okay. What else? Network configuration. We have a new interface called network configuration, which allows us to manage all the communications in one project. Because sometimes we use Ethernet communication for HMI and Ethernet IP for another controller. RS485 for VFD, CANopen for. It's quite difficult to manage all these communications at the same time. You need to go dedicated software for each. But here in the network configuration, you can see all the products in a one page, and you can see all the protocols with a different color. And when you click the communication protocol, you can directly go this dedicated page to adjust all the settings regarding the communication. Okay, so I will show it to you. How does it work? Hardware configuration. As I see, some of you already use ISPsoft, Delta PLC from your questionnaire. So you're already familiar with the hardware configuration. So in ISPsoft, still we have hardware configuration to complete all the settings easily. We will see this one in the example. And powerful programming editor. Here you see it supports LD and ST and SFC and also C language. Yes, these four are supported right now. So here you see on the top part, we can define the local variables, and at the bottom part, body program. So we can write the user program over here. For SD, we can minimize and customize for if blocks, and same for ladder. So there are some improvements for PLC programming as well. Online, offline, download and upload. Let me talk about these two. This is something useful. We have one download or download upload manager, so it allows us to download all the project in one time to all device. So it is kind of a batch download. So for instance, what you need to do normally, you need to connect first PLC to download, then second one download, go to the VFT to download, and go to the AfterSoft for server. But here in this designer, since they all included in the project and they all connected at the same time, you can also download all in one. Here you see the example, upload download manager. Here you see the controller one, servo and drive, and you can choose which one you want to download or if it is available right now or not. And you can see the status also, which one is download or not. Offline mode, yeah, for sure, it is possible to use offline mode. So yeah, we can create all the project offline, and we can without real hardware, we can make a simulation, offline simulation. And we can also check the device status in an online mode. How about diagnostic and device information? Here there are some improvements as well. So this is the interface for device and error information for CPU, for instance. Here we see all the CPU information, and we go to error information and error checklist. I will show it to you, but right now we receive, or we all face that, okay, there is one error and there is an error code, but we don't know what does it mean, and we are going through to manual. So in the error checklist, you can see all the error codes and explanation in one page, and also possible reasons. So it will save some time. Instead of going to manual, you can directly check, okay, what is this error? What is the meaning? What should I do? So that's why we have improved diagnostic information. PLC programming, yes. Apart from PLC programming, it is IEC 61131. So it supports all PLC open standards, POU, the data-defined user type, data type user defined. So it's all supported. But on the other hand, DIADesigner has a library management. What does it mean? So user can create their own library, and this library can be shared between engineers or with the end user. And for this library, there are two ways. One is create the DIA library project. So it means that you can use, also you can see the source code inside the library. But if you create a compiled library files, it's just possible to use it. I cannot see the know-how inside, user project inside. So this library system allows us to share information or project between us. Here you see an example, for instance, these are Delta defined libraries. So DIA standard. So in this library, there is a tone, TOF, etc. So, you know, for the timer, we have TMR. We don't have tone and TOF. So with this library, it's also possible. So not only Delta, but also as users, we can create our own library and share with us internally. Okay. So motion, actually, when we are calling motion here, it's not really motion controller, it's pulse controller actually. But we have an interface. So this interface allows us to create different points with the pulse output. So if you want to control motion with pulse output, you can use position plan table. So here you can set the axis settings, pulse output type, and we can protect it. We can create the position table setting, and even we can monitor we create the position, and we can see for the 2D how it looks like. Okay, how about commissioning? So for the commissioning, we have monitor table and data tracer and logger. For inverter, we have parameter editor for sure, and trace oscilloscope, and internal PLC monitor table, and communication test tool. For servo, parameter editor, oscilloscope, and gain tuning, and motion control setting. And for the temperature, same, parameter and monitoring. So for commissioning, for different devices, we have different tools. And as I said, it's also allows us to share directly the variable between the designer and their screen. Okay, it was all that I want to show regarding the designer. So let me check the questions first if there is. If not, maybe we can give a 5 minutes break. Then we will start the hands-on in the DIADesigner environment. And if you have the hardware, you can also follow me, and you can also do in your system. Let me check the questions. Okay, so far I cannot connect to my AS200. No chance to upload. I guess you mean AS200 and DIADesigner, and I have also AS200, and I will use. We will do it after the break. Yeah, after the break we will do it. So hopefully you will see it. Okay, let's give a 5 minutes break. Then we will be here 11:10. Okay, see you after the break. Okay, after the break, I guess we can start with the hands-on. Let me check if there is any question. How can I update the firmware of AS300 PLC? Firmware update is not possible automatically, so you need to contact with us. Send an email. Which firmware version do you have? Then we will check that if there is a newer one or not. So we will let you know. Okay, so send an email, please. Okay. So before open the software, well, yeah, let's start with the software directly. So let me get it here. And I guess you can see the DIADesigner. So this is the startup page for DIADesigner. So when we open the DIADesigner, this is the first page we see. And here there is a document center and servo wizard, inverter wizard. So for these two, I will not touch today. But I also want to mention about customer feedback. So this is the part that you can leave your questions regarding to DIADesigner. But please try to separate between the hardware questions and the software questions. If there is a question related to software itself, you can use this customer feedback area to type your questions as well. Okay, so for the project management, so this is the part that I mentioned. This is the basic view. And when we go to the advanced view, you will see the project tree over here. So let's go to basic first, and let's go to project. So what options we have? We have open an existing project. We can create a new project, or we can migrate the project from the ISP soft. Okay, so let's start with the new project. I need to define the project name. So let's go March. And type is, this is the area that you choose. You want to create standard project or library project. So let's do the standard project. And this is the place that we save. And also possible to define the author, company, and description. Okay, so for now, I'll just skip that. And when I click the OK, here you can see the project name. And here there is nothing right now. This is an empty project. So we can click here to add a new device, or let's turn back and go to device. So in the device part, it is possible to manage the devices in the project. So here we can monitor the existing project, existing device in the project, or we can create a new, we can add a new device. So let's add AS200PX, for instance. So I choose the series, I choose the submodel. On the right-hand side, you define the quantity, how many AS you want to add. And here also there is a small picture and description about the model. Okay, and it is adding to project. So, okay, it is done. How we can understand? So when we go to show device, here it shows that in this project we have one controller, and this is the model. So I can add another things from this menu quickly. Here in this program section, we need to choose the device first, and then we can create a POU program directly from the basic view. Okay, so here you can choose program and function block, and also the language. Okay, so this is just a simplified interface to create a program only. This is not the place that we write our codes. So let's create like test. Okay, and add. So here it is inserted. This is program and the language is later. And we can go to variable section to monitor the variables. For instance, variable default tag table. So I can add also variable from this menu. And there is a debug settings, etc. So this is the basic view. Let's go to the advanced view. Here on the advanced view. So as I said, this is the tree of the project. And this is the network configuration, the one we talked. And here it starts all the PLC settings. Okay. And you will see that under the programming, there is a program. And we call it test. So here you see it is red cross because right now we add program to project, but we didn't say PLC to execute. So we also need to define when this program needs to be executed by PLC. So assign PO, U and call test, and it is done. So when I open this one, you will see that I add this program to first task. I will not explain the task manager or what is the differences between, I mean, how does it work? Because from your questionnaire, you already use PLC, so I assume you already know. So I will not explain. This is how we assign. And what else? Let's also go to network configuration. And under the network configuration, here we go to network view. Yes, it is the page for network view. So here we add new devices, add device, so we can add manually, or what we said, it is also possible to scan directly. So how to scan? Here we are going to network scan by PC, and then choose the right COM manager, and we can scan it. But before choosing the right driver, so what we need to do, for sure, we need to also set up the COM manager. So okay, from here, let's jump to the COM manager. Let me open it. So it is how it looks like. So on the left-hand side, you see the existing drivers you created. So COM manager, you know, it is kind of middleware between software and hardware. So what we need to do, we need to create a new driver, or we can delete or modify, whatever. But in addition, I also want to show these three tools. DIACom is just for interchanging to DIACom software. But in addition, we have IP manager and ping test. So simply ping test, sending a ping to device, which device is available. And IP manager allows us to control the IP address of the PLC, which has a DHCP functionality. So we can control the IP address from the IP manager as well. So these are the tools we have. And let's create a new driver for now. And here, you need to give a specific name for each driver. So let's call it training. And connection setup. So here we have different types. So USB, Ethernet, serial. Today I have an Ethernet connection, so I will use Ethernet. And connection type general and device data. So you choose the Ethernet card of PC, and when we search it, COM manager will check which devices we have in the network. There is a question. Wait a second. Can we see this presentation later? Yes, you can. I guess we will share, but when we finish all the sessions. Okay, so not today, but yeah, we will share them. On the other hand, as I said, for most of things that I will demonstrate here, we will upload also YouTube. Okay, so when you follow the YouTube channel, you will also see more examples over there. Okay, right now it seems I have a Ethernet connection problem. Oh, wait a second. Let me create a new driver, and let's call it different name and search it. Okay. So here you see in my network right now, we have two PLC, 5 and 7. And on the left-hand side, you can also see. Right now, there is no any other connection from one PLC to another, so I cannot see any sub. But if there was a VFD, for instance, I can also connect that one. Anyway, after see the devices that you want to connect, and if the IP address, everything is fine, then you need to say the driver. Okay, so com manager is done. So it means that your PC and the PLC is connected right now. But it doesn't means that DIADesigner is connected. Just PC can reach to PLC. How about DIADesigner? So we need to go network scan, and we need to choose the right driver, and let's scan it. So here, this two is founded. Let me delete this one to make sure that we have the right device. Okay. So right now, see, it is automatic live. So any change you made here will imply directly to project. So I will search it again, and I will choose these two CPU, and saying that, okay, add to project. And when I said add the project, it is not only network view, but also the project tree will be updated. So that's why it is taking some time. So first one is done, and also adding the second one. Yeah, second one is done too. So here on the left hand side, you see the controller, and also here in the network view. So this is how we scan and how we can add to project. And on the bottom part, you can define the settings related to communication. Okay, so here you can set the related parameter related to Ethernet IP, and also can open. So what else? Here we can make a quick connection, but let's do it later. We will show Ethernet. We will do Modbus TCP or Ethernet IP afterwards. So for now, just we use network view to add current products to project. Okay. So, but as I said, this is not enough to connect for DIADesigner to PLC. For that, we need to go specifically for each controller, go to communication setting. And here, you need to choose right driver, right IP address, and you need to click OK, connect. And when you see connected, now it is fine. Now DIADesigner can connect. Okay. So I also need to do the same thing for controller 2. Let me go communication 2, connected. Okay. So right now, there is a communication between DIADesigner and the PLC. Okay, so let's jump from here to hardware configuration. So I will go to hardware configuration. It's separated user interface configuration and parameter setting. So here in the configuration, we can define which devices we have, which modules we have. Okay, we can simply add new module here manually, or again, we can simply scan the real network. So I click OK, and it is done successfully, but right now I don't have any module. So that's why there is nothing. Wait a second, let me do the same thing for first controller. Okay, I go to the hardware configuration of the controller 1, and I will scan it. Here, for instance, this CPU has a module 06XA, which is analog module. So automatically I can see here, okay? And when I double click it, it goes to settings of the module. Okay, so today I have analog module with me. So let me show my setup. New share, advanced content from second camera, yes. Yeah, I guess you can see it. A bit blurry, but that's fine. So right now I have 218px. Okay, so this part is the analog input output. So this analog input output in the CPU itself, and I have additional analog module over here. And I mentioned you before that the analog module itself needs 24 volt DC. So these two red and black cables are for 24 volt DC. And actually I got this 24 volt DC from the power supply directly. One of you asked me that does it necessary the power supply is mandatory? No, it is not mandatory, but as you see, there are some functionalities like this. So I can get an additional 24 volt over here to supply the module itself. Okay. Right now, I don't have any analog source. So that's why what I do, I connect, I use the built-in analog I/O as a voltage output, and I will use module as an analog input. So I will generate from CPU, and I will read from the analog input, analog module input. Okay, so this is what I have as a setup. Okay, so let me turn back. Okay, I guess now you see the software again. So that's why we have XA. So what we want to do, we want to use PLC analog output and read that analog output from the module input. That's the idea. So what we need, first we need to understand how we can use built-in analog output. Okay, for that, here we need to, we need to go AS series hardware manual. Okay, so in the AS series hardware manual, you will see here, let me show from here, I guess in the wiring, table of content. Yeah, here, AS200, right now I have AS200, if you remember, analog input output specification. So this is specification for the built-in analog. So we have two analog signal input and two analog outputs. Right now we will focus on the output, right? So for the output, here we have two options, minus 10 to 10 volt or 0 to 20 milliamp. So let's use voltage output. Okay, and here you see the resolution from minus 12 to minus 2000 to 2000, and this is the address where we use inside the PLC. So this is the address that I use to generate voltage output. Okay, so let's this is the first part. Also, let's check the analog input module. So for that one, I need to go AS series module manual because it is module itself, and the module is 06XA, right? If you remember, here it shows how to use with ISP soft and DIADesigner. Okay, well, this is DIADesigner plus, so this is code based. Okay, I guess we have a question. Wait a second. Is there any protection for short circuit on analog output 010? Good question. There should be. I'm not 100% sure, but there should be. I need to check. Okay. I will reply you separately. Should we add delta power supply in the hardware configuration? No, it is not mandatory, but just to show the real exact configuration, yeah, it will be nice to add, but it is not mandatory. Without having a power supply in the hardware configuration, it will not be an issue. Okay, so here we set it 0XA, and this is the area that. Okay, sorry. Yeah, let's go to specification part. So we said that we will use as a voltage input. So here you see there are different options for voltage, and the resolution is between 0 to 32,000. So what does it mean? So if you remember, for this one, it was 2000. top, and this is 32,000. So for this module, 10 volt means 32,000, and for this module CPU, 10 volt means 2000. So this is the resolution differences. So, and it can be most of time the resolution of the source and the receiver is not same. So we need to make scale, right, between them. So I will also show them how to. But let's use with the default settings first. So let's go to hardware configuration again. So I will go to CPU, and here inside the built-in digital input output settings. So this is digital input, analog channel output is, yeah, voltage, already voltage, and already voltage. So I don't need to change anything. Okay. So let's go to module. And let me start with this one first. Here inside the mode setting, we can define how we want to use. Okay. So I set it 0, 10, 4 of them. So let's leave it there. And also there are other settings like calibration, average filter, etc. So you can see all the explanation in the manual, the one I showed you. Okay, so this is actually more or less setting for for analog module. So you just need to define what you want to use, and you need to make the wiring. That's all. And then we need to download. So how to download here? Well, let's compile first. So there are two different compile. So the compile this one, compile the controller that the project is open. Right now, for instance, it is controller 1, right? So it is just compiling the controller 1. But this one compile whole project. Let's compile the whole project. So right now says that there are 2 errors. So at least one program must be. Okay, so we created an empty project, and so that's why there was no project inside. So first I need to create a program. Just for test, let's create the empty one. So it was for program for controller 2. Okay, and for controller 1, I will go to programming, and so we just create an empty program, and let's compile the project. So see, there is no error anymore. So it is possible to download. So here you can define which controller you want to download. Before download, let me check IP address as well, because right now it is an empty project, so maybe it changed the IP address too. So if I'm not wrong, it was 5. Okay, so let me check in the hardware configuration. Okay, this is 5, so it will not change when I download. And for controller 2, it is 7. So let me check the Ethernet 1.7. Okay, so it means that when I download the hardware configuration, the IP address will not change. Okay. So I can download both of them. Here you see at the same time downloading 2 of them. And we can also see the status. So see what is downloaded, which is success or not. Okay, so right now it seems okay. Let's close it. And let's go to controller 1, because this one has an analog I/O. Okay, so we will work on controller 1. So let me minimize the controller 2. And what I am going to do, for simply to monitor the values, we use data table. So for data table, monitor table, you need to go commissioning and add monitor table and click OK. Okay, what was the address for the analog source? SR172. So it means that I need to add SR register SR172. Okay, so this is the analog value for us, and so we also need to read from the module, right? But we didn't check the module address, and one of you asked about it. So to check the module IOs, we need to go hardware configuration again, and in the hardware configuration, when wait a second, when I choose this one here, I can see it starts from the for input 28,000. And the first one is related to error, but here you can see the detail. So the first two word, double word, belongs to error code. So the first channel is 28002. So simply I need to add 28002. Okay, so this is the source and this is the receiver. Let's try if it works or not. So what I need to do, I need to go online. And when I go online, here at the bottom, you can see the scan time. And you see the capacity of the PLC and the capacity that I used. I only use 1% so far. And here you see that we are online and it shows the status of the CPU. So it is now on stop mode. So it means that it does not execute the PLC program. So I need to make it run. So here I go run button and click run. So and the monitor here. So it is run. So CPU is executing. Okay. So right now, more or less, you see there is a value over here and it is changing. So this is our analog receiver. It means that there is something, but for sure there are some, right now I just use 2 cables, so there are some slip. So let's try to send 10 volt. And for 10 volt, what we need to do, if you remember, the resolution is up to 2000. This is the scale inside the CPU. So for 10 volt, I need to set 2000, right? So 2000 here. I sent 10 volt and the module received 10 volt, but module converted as 32,000. The reason is that they have a different resolution. Here we show it. So 32,000, 10 volt. So that's why they are on different scales. Same value, both of them 10 volt, but different scale. So what we need to do, sometimes we want to work in the same range, or I want to change that. No, I want to see exactly the same. If it is 10 volt, it should be 10 volt. If it is 5.0, etc. So for that, let's do that part. I will go offline and I will go configuration again. XA. So for that we have two way to do it. Calibration can be, and for calibration here there is an explanation. Functions. You see the here is the calibration where it is explained. So this is the formula. So you can play with the gain and offset to make calibration, or the easiest way, we can go to mode setting. Sorry, we can go to format and we can change format from integer to float. So CPU itself convert it automatically, and you are defining for the input channel 1 what is the minimum and the maximum point. So for the minimum and maximum, I want to see 0, and for high point it is 10. So right now, instead of 32,000, we will see 10.0. But do not forget, this is float format, okay? So it means that after this time, you need to work on float based for this analog value. Okay, after make this change, let's download. We are using controller 1, so no need to download controller 2 for now. Okay, success. So I will close this and I will go to monitor table again, and I will go online, and here, okay, right now we set 2000, 10 volt, right? But here it does not make sense. The reason is that we changed the format. It is float anymore. So what we need to do, we need to choose float. And float is double word. So that's why we also need to change from word to double word. And we need to choose floating point. Here you see more or less 10.0 volt. So for 5 volt, for instance, here you see directly to 5 volt. So it makes simple for us. So CPU directly convert it. So you don't need to use additional instruction to scale it. Okay, so this is how analog works actually. It is quite simple. Let's go to the programming part. Is there any question? Let me check. Can you also download specific VFD parameters at the same time in a different layer? Yes, it is possible. If the drive is connected to PLC, you can reach to drive and you can download some specific parameter for VFD. That's possible. Okay. So for programming, so we talk about task manager simply, and let's start with the programming. This is the area we use for programming. So here you see this is the part that we define the variable. So depends on the user. Some users prefer to work as variable based, some address based, and that's why here in the menu, it is possible to change the mode of the interface. So if you would like to work on variable based, you can choose variable only, or you can see variable and address at the same time. So it is quite flexible. But I will start with address first. And let's do something related to analog, and let's make comparison, float comparison. If it is higher than 5 volt, give an alarm, let's say. Okay, so I put here, we are using this one to put contact. Which contact we have? Normally open, normally close. These are similar with ISP soft, and these are the possibilities. And this is the coil part. So output, set, reset, same. So jump function and insert network. This is rising edge for the network. So this is the part for comparison. Okay, you can make the double comparison, float comparison, etc. So here you can show and hide the network command. Network command is this area. Okay, you can give a specific title and command for each network. And this is the mode we choose. Enable, disable the selected network. So I can disable the one, for instance, and I can add the instruction block, function block here, and I can also add label. Okay, so I will minimize this one, and let's add a contact. This is a way to add a contact, or another way, like as ISP soft, we can directly type, and when we type something, we can see the instruction here. So for the contact, the shortcut is LD, actually instruction list. It comes from instruction list, LD, and then we can define like this. But here you see the question mark. It means that we also need to define the name or address. Okay. So for the address, if you remember, for Boolean, we can use M area, M memory, and for instance, M0, let's use. And here I can define a start comparison. Okay. So what I want to do, I want to compare two values, right? I want to compare the analog value. So here there is a comparison, and I want to check if it is bigger or not. So here, checking that. So this is the area that 28002. If you remember, analog value source, the one we used before, 28002. and I am comparing 28002 with 5.0, right? And at the end, I will get what I will get, coil. And for the coil, the shortcut is O. And let's use the real output. So here you see, if this when I enable this one, comparing the analog value, if it's higher than 5 volts, the first digital output is on. Okay. So this is the first thing we can try. What else we can do? We can make a, for instance, if it is 5, there is an output, but in the factory nobody focus on that, so we can give another output when it is higher than 7 volt. So we can make a blinker, for instance, for the light. Okay, so let's we say that above the 7, so we need to use another compression. So we can directly copy these two. What I did, I choose these two, okay, and then Control C and Control V. And I want to compare with 7, and I want to set M10, let's say. Here, M10 is internal variable, and I use internal address because with this address, I want to trigger blinker, right? So here I will add another network, and this is the part that I will write my blinker. So first, to trigger the blinker, I need to use M10. So M10 will control my blinker. And for the blinker, what we need for sure, we need timer. And what is the timer for delta? We can, if we don't know what is the function block, we can simply go insert function block section. No, wait a second. Where is it? Select, okay. But this is function block. So this is for function block. Then we need to go over here. From the toolbox, you can find the right instruction. Then you can add manually. So this is a way. And another way is that you can go to guide and manual and instruction manual. And here inside the search, we can write timer. So here you see some instructions related to timer. So I already know this one, so I will click directly. This is the code for timer, okay? So what I need to do, simply come here and start to type TMR. And when you click enter, you will see what inputs and outputs you have. So if you don't know what is the input and output, simply you can go to, again, help page. And in the help page, it refers you what is the S1, what is the S2, okay? And what can be the type of S1. So S1 can be T memory only. So I have to use as a T memory. And this is timer. And S2 can be word or integer, okay? So it has to be T memory. So I will use just simply T0. And this is the area that we type the time. So I will use simply 5 millisecond. So when the M10 is on, T0 is on. So I need another rack and I need another coil. So over here, I will type T0. So what does it mean? So as you see, T0 can be a word and bit. So here I use as a bit. So when the timer is on, when the timer reaches to 5 milliseconds, T0 will be on. And there, I will I will use another output, real output 0.1, for instance. Okay, so this is on. Then I need another timer to disable it, right? So here I will again simply type TMR, and this time I want to use another timer memory T1 and another time 10. 10 is 1 millisecond, and the reason is that when you go to the help, you will see this timer is 100 milliseconds. So any value you wrote over here, multiply with 100 milliseconds will be the time. So this is 1 second. So okay, so this is on, timer start to count, reach to 5, then this is on and it starts to count, and when it is on, we need to initialize this. So how can we initialize? Simply we can put the normally closed contact, okay, and the shortcut for normal contact is LDI, okay. So delete this one and let's use this. So right now we are comparing analog value with 5. If it is higher than 5, this is the first output. If it's higher than 7, then blinker will work. Okay, so again, let's download it. Okay, so it is done, and I will go online, and here you see it is in run mode, and I need to start the comparison, and I said true. So right now PLC is executing and the condition is not met, so that's why this is not on. So we need to send higher than 5 volt. So what I need to do, I can do like this, go to window and horizontal to show monitor table and the programming at the same time. So over here I will go to programming. Sorry, where is it? Yeah, okay. So what we said that we need something more than 5 volts. So let's set, so more than 5 here you see, and this is also more than 5, and okay, this is on, it should be on, but not. Let's see what is the problem. Here we can also monitor the value 5.4. Yes, bigger than 0, that's fine. This is running. Let me stop it. This was about the ladder diagram. Okay, so it is more or less same like ASP but it is there are some improvements on the other hand. So check it out. Let me see. There are some questions. Can you sort the products and see if the PLC has hardware problem? Yeah, I tried with the simulation as you see, and yeah, same thing. So I will check it later. So let's have a look also the structure text part quickly. Okay, so for the structure text, again we go to program and right click and add program and add ST language. So this is the part we choose our language for PLC programming. So this is the part we define the R code. So here again, what we can do, we can work as address based or variable based. If you want to work as variable based, first you need to create your variables here. So for instance, let's create a variable which is double integer, let's say, and let's call it here. This is important. Right now, as you see, there is no address. So it means that it is auto mode. So PLC assigns some address to it. So you don't need to think about where it is stored. And here we can add another one, which is Boolean, for instance. And let's another one, which is double integer again. Okay, so and here there are some helpful things. Again, we can add our delete command. or we can use, for instance, you can add if, so it is a sample code simply. What we can do, for instance, we can do something like, okay, if boolean var2 so var1 will equal to var3. So here when you type a few letters, it will show, it will filter what are the possible variables that you can use. And also here at the bottom, see, you can filter what you want to see. Show local variables only, or show global variables, etc. So for instance, we can do something like this. And when we compile, it will show you if there is any error or not. So from the ST point of view, there is not much differences. So just there are few tools that which are helpful. So if you are already familiar with the ST, it is same principle. You can just go and type directly. Okay, as a last, I guess we are running out of time. As a last, I also want to talk about communication one more time. Communication between devices. So for that, I will go to network view. Okay. So here we say that we can scan the network to find the devices. And also in addition, we can define the communication at the same time. How? Simply we can click to write and quick connection. Or you can do it by yourself. This one will go line 1. This one will go line 1, 2. Okay. So you can also draw like this. So this is just overview, but where is the data exchange that we did? So for that, you need to right click to 5, the port number, or depends on you, which one do you want to set as a master? If it is 7, then you need to choose 7. So 5, data exchange table, and choose which protocol you want to use. Yeah, let's do Modbus TCP. Here it opens a new page, and here you can see for the Ethernet there are 2 devices under connected to each other. Here you see the only Ethernet network. Okay, and at the bottom you see the communication parameters. So simply you are master 5, and you see it is marked as yellow, and slave is 7. So that's why you choose the IP address 7, and node address is default 1. And this is the area that we make the data exchange. So you can use this table, or you can go to setting to make an additional advanced setting. So it is same as ISP soft. Here we can choose if it supports, if the slave supports function code 17 or not. Then we can let's choose, for instance, D. Let's get the value from D200 to D100, and we need to choose channel first. So let's get value from D104 to D204. Okay, and here is the area that how many data you want to copy. Let's copy 2 and click OK. So here you see the overview. So when we download it, you will see the values on both sides. Well, we can, but we are running out of time. So right now I will not demonstrate, but this is like data exchange we use in ISPsoft. So this is the interface. It is similar like ISPsoft. So when we download it, you will see the communication. And same for other protocol networks. So here, when I go to the, again, network view, so you can also do the same thing for CanOpen. Okay, you can also do the same thing for RS, but the principle is same. So first create the network here and then make the communication settings on the right hand side. Okay, so it was the things that I want to talk about today. I hope it was helpful. So I don't know if you already download and start to work with DIADesigner, but feel free to do it because it is free and offer many features. So yeah, it will have a look and just let us know your opinions and your feedbacks, like cross-reference. We already receive it and this is in our list. So just, yeah, feel free to try and let us know as usual. And if you have any question, let me know. Otherwise, it is the end of today's session.